Today we are going to discuss methodological interpretation of fertilizer experiment. This may be a new topic to you. I want to explain you what does it mean. Methodological interpretation of fertilizer experiment means that whenever you conduct the experiment on fertilizers, you will get some output, you will get some yield, and at the same time you must have used number of fertilizer rates, variety of fertilizer rate. So how to interpret, how to understand the relationship between fertilizer application and the output. So that there are certain methods which are used to understand relationship between fertilizer application and your output, which is normally economic yield, or otherwise it can be called as economics of fertilization or economics of fertilizer use. How we can calculate the profit out of fertilizer application, or it can be achieved through the response curve fitting. So all these three topics are almost same, are related to each other. So I have already suggested some references to you. For this particular topic, you can see number 3, Estimating Fertilizer Requirement, a Quantitative Approach by J.D. Colwell. This book is available in IRI library. Unfortunately, you cannot access it. However, I have already given you one book, Soil Fertility Evaluation and Control. It contains very good topics, some interesting subject, soil fertility evaluation and control. You may like to see this book already with you. There are some more references. You need not to bother about these references. I will give you notes related to this topic. So you need not to worry much about the study material that will be provided to you. So overall, what we are going to learn out of this lecture is fitting of response curve. How to fit response curve? What do we mean by response curve? Then the difference in correlation and regression analysis. After that, we will see fitting of linear and quadratic equations. These equations are also called as models. These days, there is trend to call equations as models. And these models or equations can be plotted. They can be presented in the form of lines or curvilinear lines. Then we will see how the optimum dose of fertilizer can be determined. That is the basic purpose of response curve fitting in our case. There are many other uses of response curves that we will like to see. And fitting of response curves in Excel. Interpretation of results obtained in Excel. Excel is your MS Excel here, Microsoft Excel. Finding the best response curve or model. So for last 3 objectives, I can teach you in extra class. It is not possible to teach in regular class because this is not part of your syllabus. In your syllabus, you have just theory part. That is 3 plus 0, I think your credit hours are. So whenever this week or next week, if you give me time, I can teach you these practical exercises. So let us start with the last lecture. Yeah, hello, Abhijit.
Yes, sir.
Yeah, do you have any problem?
No, sir.
Is it okay? Okay. Anyway, so we start with the last lecture, and in last lecture we have seen what are different factors that affect the growth of the plants. So you see, yield depends on the growth of the plant. So we need the optimum growth. We need good growth of the crops, and then good growth only can give you better yields and then economic returns. So we have seen some factors that affect the growth. Number one was genetic factor or internal factor. So now question comes, can we have any control on genetic or internal factor? So you see, I have written inputs on the right side. Yes, we have control. We have control on genetic factor. Means farmers can change. Farmers can choose the variety. They can choose the seed. They can choose the seed to manipulate the growth. If you want more growth, better growth, high growth, more tilling. One can go for hybrid varieties or hybrids. Similarly, seed of certified seed, foundation seed, those kind of seed will give you better growth than the farmer's saved seed because that seed is in better in quality. Next is your environmental factors. Abiotic factors includes your wants plus light. Wants you have W, water. So water will become an input. Now we are dealing it as a factor of growth, but it will become an input in the form of irrigation. Irrigation. Similarly, A for atmosphere. So on atmosphere, farmers will not have much control. Then nutrients, N for nutrients. So this nutrient will become in terms of fertilizer. It can become in terms of fertilizer. So nutrient was a growth factor, but it can become as a input also, as a fertilizer or organic sources or biofertilizer. Next is your temperature. Temperature cannot be controlled much by the farmers, so it is not considered in the form of inputs. It is actually natural resource that is received by the crops. Next is your soil or somewhere to grow. So this soil is also an important factor in important input you have seen. It is a fixed resource. Then light. So overall, what I mean to say is here is just you see the biotic factors. Biotic factors includes your weeds. So weed management will become input. Control of weeds will become input or doses of herbicide. Doses of herbicide or pesticide or insecticide will be used to manage the biotic factors, can be used to manage the biotic factor. Then these pesticides or herbicides, they will become your input. And then management factors, in management factors, you have number of factors, starting from manure addition, your tillage, time of sowing, time of planting. So we have two kind of inputs in agriculture. One is monetary input. Monetary input means where farmers need to spend the money. Other is non-monetary input. Non-monetary inputs or low monetary inputs where you use very little amount of money or money is not required. For example, time of sowing. Time of sowing uh, does not involve any money, any extra money. So suppose if I plant a crop today, I can plant that crop after 10 days also. But what should be the best time of planting? So that is non-monetary input. Similarly, your spacing. Plant spacing is also non-monetary input. But there may be some monetary inputs also. So management plays very important role in making the decisions. So overall, what you can see that these are the inputs which, for example, seed, variety, irrigation, pesticide, fertilizer, nutrients. There may be many more inputs which are used to manage or used to control the growth. So these factors of growth can be manipulated uh, by the use of inputs. And these inputs will give you some economic returns in the form of yield. These inputs will be transformed in the form of yields. So overall, what are the objectives? Number one, we want higher yields. Of course, we don't want lower yields. We want higher yields, but at optimum levels. There should not be excess or too high yields. How it is possible, how it will benefit, because it will increase the returns. If you get more yield, you will get more money from the output. Other objective is to higher yields per unit of input. More yields per unit of inputs means more returns per unit of input. Here we want to increase the efficiency of the inputs, and this will reduce the cost. So your cost is reduced, your yield of the produce is also high. So that way your economic returns will be high. So overall, we want to optimize the yield and level of input. What should be the level of input that gives us the optimum yield? Optimum yield means most economic yield, where farmers will get maximum benefit. So in this case, we want combination of the inputs or level of inputs. So in this case, I'm not teaching you complete economics or agricultural economics. I will restrict here only to the fertilizer input. Fertilizer input, relationship of fertilizer input or nutrients to the yield of the crops. Now question come. First of all, a question come, if you want to supply fertilizer, if you want to supply nutrients through fertilizer, then what should be the level of nutrients? What should be the rate of application of fertilizer? So how farmers can decide the rate of application of fertilizer? The first option could be visual plant diagnosis. Visual plant diagnosis means you just go to the plants, go to the crop and see the deficiency symptoms or symptoms of toxicity or symptoms of excess uptake or availability of the nutrients. So visual plant diagnosis will tell us the deficiency of a particular nutrient. And we know deficiency symptoms of nitrogen, phosphorus, potassium, or we also know the toxicity symptoms of nutrients. So if your leaves or older leaves are getting yellow, that means you may have deficiency of nitrogen. Similarly, for every nutrient, you have deficiency symptoms. So I think you will not agree that through visual plant diagnosis, we can decide the dose of the fertilizer. It will give us hint that a particular crop or particular plant is deficient, but it will not dictate us, it will not teach us that how much or what quantity of nutrient should I apply. Number two is plant tissue test. Okay, plant diagnosis is not giving me answer. Let us go to next step. That is plant tissue test. So certain rapid tissue analysis is possible. One can take plant samples, maybe leaf, maybe shoot, maybe any part of the plant which is recommended, and that plant tissue can be used to see the status of the nutrient, and it is qualitative test. It will not give you exact the concentration of the nutrient. It will tell you that whether a nutrient is level is low or nutrient level is medium or nutrient level is high in the plant. So plant tissue tests are also not useful, that can tell us that how much fertilizer should be applied. Next comes the plant chemical analysis. Means here it is quantitative analysis. Here we can take the plant tissues and those plant tissues can be analyzed for essential plant nutrients. And we can see that what is the level of nutrient in the plant. Suppose there is 2% nitrogen in the rice shoots at tillering stage. At tillering stage, suppose there is 2% nitrogen concentration in rice. So again, it is telling us that nitrogen level is 2%, but we do not know whether this 2% is sufficient or insufficient. Or then by knowing it, how much fertilizer, how much urea I can apply to overcome this problem. It is again not a very good idea to apply fertilizer based upon plant chemical analysis. Then comes the critical values. Now we know the how much nutrient content is there based upon plant chemical analysis. So people can determine the critical values, that what should be the critical values where a farmer or a person should apply the nutrient. So it will tell us the time of nutrient application. But these critical values will again not tell us that what should be the quantity of the fertilizer. So critical values we will discuss in detail what is critical value. Then okay, let us go for soil chemical analysis. These critical values are also not useful in deciding the quantity of the fertilizer. Then let us test the soil. Soil testing is done to see the status of available nutrients, mostly to test the status of nutrient availability. How much is nitrogen, how much is available phosphorus or available potassium in the soil. So we go for soil testing, we take the soil sample and different tests are available and we see the status of available nutrients. So there may be status may be low, medium or high. Based upon this, some recommendation can be given, but they are not having any good scientific basis because the nutrient supply capacity of the soils will vary. So this is again not a perfect approach to give recommendation of the nutrients based upon just soil testing. Then people say, let us do some pot experiment to decide the requirement of different nutrients by the plants. So again, pot experiments are useful. They can give us some indication that this particular nutrient is absent or deficient, and but they do not represent the actual farming condition, actual soil condition or field conditions. Therefore, pot experiments are not much useful in telling that how much fertilizer or nutrient should be applied. The best option and final option is that field experiments should be conducted under different soil conditions at different rates of fertilizer. So this is the best way to find out the fertilizer requirement and apply the fertilizer according to that. And these field experiments can be used to decide the optimum dose of the fertilizer, because it also includes the contribution of soil towards meeting the nutrient requirement of crops. Now, question comes that what benefit we can get by finding the optimum level of fertilizer. We want optimum level of fertilizer to increase the income, and also to reduce the pollution of the environment. So, some of the fertilizer create pollution, particularly nitrogenous fertilizer. Denitrification, ammonia volatilization, and leaching losses. The water is polluted and air is polluted. So, if we make efficient use of fertilizer, the fertilizer application will result in less pollution of the environment. So, it will give you best economic returns and lower pollution of the environment. So, therefore, optimum rate of fertilizer should be used. Any question up to now? I just introduced you the topic. If you have any question up to now, or from the current slide where I started with, yeah,
Sir, sir,
yes,
sir, is there any difference, actual difference between plant tissue test and plant chemical analysis?
yes. See, plant tissue test, what we do, we simply take the plant tissues and take a pestle and mortar. In pestle and mortar, we crush the plant tissue and we just put some solution, and then we see the development of the color. Here we see just the development of the color. Color may be light. For example, in case of iron deficiency, we take the plant tissues, we crush them, make their paste, and then put the extractant. Some extractant is used, solution is used, and that will develop some color. So if the color is light red, then there may be iron deficiency. Color may be medium red, then medium level of nitrogen, and color may be deep red. If it is deep red, then it is having sufficient iron. But it is not telling us that what is the exact concentration of iron in the plant. So these are very qualitative tests. And in plant chemical analysis, this is quantitative test. Through these plant chemical analysis, we can know the exact concentration of the nutrient element. So plant chemical analysis will be helpful in deciding the critical level of a particular nutrient in plant tissue. For example, as I told you, example of rice at tilling stage, there should be about 2% nitrogen in the rice tissues. So through plant chemical analysis, we can know the critical values of a particular nutrient. So that is the difference in plant tissue test and plant chemical analysis.
Thank you,
Is
sir.
it clear?
Yes, sir.
Okay. Any other question? No problem. We go ahead. Now, see the critical level. Critical level is the level of concentration of the nutrient in the plant or in soil that is likely to result in 90% of the maximum yields. So suppose you get 100 unit of the 100 unit of the output, or 100 kilograms of yield. and instead of 100 kilogram, you get just 90 kilogram. You get 90 kilogram. So at 90 kilogram, what was the concentration of the nutrient in soil or in plant? That will be your critical level of that particular nutrient. Critical level means the level of the nutrient in the plant or in the soil where you get 10% reduction in the yield, 10% reduction or reduction in the yield or growth. That is your critical level for deficiency and critical level for toxicity. It can happen both ways. Sometimes your nutrient concentration is very, very high and it is affecting the growth of the plant. The growth of the plant is reduced, the yield of the plant is reduced, then you will have certain amount of that element in the plant that will be toxic to the plant. So that also reduces the growth and yield. So therefore, critical level for toxicity is also available. Critical level for toxicity in soil as well as in plant. So this is how we define the critical level. The level of the concentration of a nutrient in plant or in soil that gives you 90% of the maximum yield, means 10% reduction in the growth or yield of the plant. So at that particular point of time, you can see the concentration of that element in the plant parts. That is your critical level. And remember, this critical level of the nutrient will vary with the stage of the plant. What stage you are sampling the plant? Number one. Number two, the species. The critical level of nitrogen for nitrogen deficiency for rice will be different from maize or from the cowpea. Similarly, the critical level of a particular nutrient will be different at tilling or at maturation or harvest stage or flowering stage. At different stages, the critical level will vary. Number three, the plant part which are being used or which are being sampled. The critical level is usually defined that this leaf or petiole has been taken from the fourth leaf or fifth leaf or from the second branch or first branch. You need to define what plant part has been used. So critical level of a particular nutrient is decided based upon three aspects. Number one, the species. It will vary from one species to another species of the plants. Number two, the stage of the plant, which stage you are analyzing the plant, and number three, which part of the plant you are analyzing. So based upon three, you decide the critical level of critical concentration level for deficiency or for toxicity. So you can see this picture. In this picture, on x-axis, you have the increasing nutrient content. The nutrient is increasing from zero from on x-axis from left side to right side. On y-axis, you can see it is increasing growth or increasing yield. It starts from 0 to 100. So you can see the line, the curve. You can see the curve. In the beginning, you see the A. A is your acute deficiency. Here, the level of nutrient in plant tissue or in soil is very low. Which is acute deficiency. And then you still increase the supply of the nutrient in soil or plant. You increase the supply, then you will see B. B is the area of latent or hidden deficiency. Here, the plant may not show you the deficiency, but it is suffering from the deficiency. So in this region, in the B region of latent deficiency, you will find critical value. And if you see the growth, here the growth should be 90%. Here the growth or yield should be 90%. Then you still increase the concentration and you achieve 100% of the maximum possible yield. Then this is your optimum level, optimum supply of the nutrient. You further increase the supply of nutrient. So in case of certain nutrients, you get the luxury consumption. In luxury consumption for certain nutrients, there may not be any toxicity, but it is accumulated more than what is required by the plant. Therefore, it is luxury consumption. It is observed in case of potassium. And then, if you go on increasing the nutrient, then you will have light toxicity. Light toxicity in this part you will get about at some point you will get about 90% of the maximum possible yield, which will be critical concentration of the nutrient for toxicity. And then finally you will get acute toxicity. As you go on increasing the nutrient content in soil or plant, on x-axis your yield level or growth level behavior of the growth changes. In the beginning it is very low, then you increase, it will come to the critical level, then optimum supply, luxury consumption, light toxicity and acute toxicity. So here I tried to explain to you about the critical concentration of the nutrient. Do you have any question on this graph, or you could follow it? Is it okay, or you want to have any question on this graph?
No question, sir.
Is it clear to everybody? Okay.
Yes, sir.
Hello, sir.
Yes, sir.
Yes, sir.
Yes,
Sir,
sir.
Yes,
sir, I have a question. Hello,
yes, yes.
sir. Is the critical level of toxicity where we will get on the point of critical level of toxicity?
Yeah.
We will get
Critical
in
level of,
light toxicity.
yeah, in the beginning you will get light toxicity, and if your level of nutrient goes on increasing in the plant or in the soil, the critical level is explained for both level of nutrient in soil or level of nutrient in plant. For both cases, it is explained. Generally, it is thought that if your nutrient level is more in soil and then plant level will be more. Generally, it is thought like this. So, light toxicity in the beginning, and then you continue to increase the level of that particular nutrient, then it will become acute toxicity. But this kind of toxicity happens mostly in case of micronutrients. Your primary nutrients, secondary nutrients, they do not have any toxicity. Some of them, like potassium, can be accumulated in excess, luxury supply, but they are not really toxic. They increase the growth. But a micronutrient like iron or aluminum is not essential micronutrient, but it is a micronutrient. Aluminum, iron, manganese, copper, they can lead to toxicity. But NPK, they will not be toxic to the plant. Now you see the
Sir,
critical, yes,
sir, some nutrients are present in the soil, but plant unable to take the nutrients. Then how we can determine the critical levels? For example, phosphorus, it is fixed in the soil, it is available more.
see,
How we can?
actually, the critical level of the nutrient is defined based on the available nutrient. Available nutrient in soil. It is never decided on the basis of total content of the nutrient. It is decided on the basis of the available nutrient. So whatever available is there, whatever has been brought to the solution or exchangeable site, that is your available phosphorus.
Sir, at the point of critical level, we have 90% production and only 10% loss.
Yeah.
Sir, then
Yes.
it should be between B and E or C and D range of maximum yield.
For here it is you get maximum yield between B and C, or you can say where the B ends. B ends. The critical level is at 90%, but here you want 100%. If you want 100%, then you increase the supply of the nutrient. So it has been
Sir, it
fixed.
means
Yeah.
that 90% yield between A and B.
See, this is very hypothetical graph. It is not a measurement. It is not exactly measurement. It is just to make you understand that what is critical value. So don't go for A and B and this and that. Just it is just to make you understand that there is 10% reduction in growth means, or you can expect 10% more increase, 10% increase in growth or yield of the plant. That particular level is critical value. And now you can ask a question. I will tell you. Now you can ask a question. How this 90% is decided? Why not 80%? Why not 95% or so? That should be the question. So actually, what happened? People have conducted number of experiments. Number of experiments have been conducted on fertilizer and yield relationship in different crops, or growth and fertilizer application, or yield and fertilizer application. In most of the studies they have found that this critical level comes at 90% of the growth stage. 90% of the growth stage, because you will decide the optimum dose of the fertilizer. Optimum dose of the fertilizer where you get maximum economic return. Where you get maximum economic return. So they have calculated based upon those experiments that 90% is the critical level. Is it okay?
Okay. Yes, sir. Yes, sir.
If still some questions are left, you can write me emails. So
Okay,
now
sir.
you see the critical level of different nutrients in plant tissues. For example, for zinc plant tissues as well as in soil. For zinc, you should remember these figures. These figures are usually asked in your interviews or your exams. So better to remember these critical values. This is given by Katyal and Ratan 2003. Zinc, if it is extracted from DTPA, DTPA is the extractant, very common extractant, then the critical level is zero point 0.6 ppm or microgram per gram. Microgram per gram is equivalent to ppm. So 0.6 ppm is the level of zinc in soil, which is critical. And then for plant tissues, it is normally 10 to 20 ppm. Manganese 2 ppm, 15 to 25 ppm. Iron 2.5 to 4.5 and 50 ppm. Copper 0.2 and 2 to 5 ppm plant. So you can go through this and please try to remember these values. At least for zinc and iron and copper, you should remember these critical values. These are very, very important. Many times they will be asked in your examination, in your oral examination or written examination. Then this data is just to explain to you how this critical level of different nutrients varies with the species, varies with the stage of the crop, and varies with the plant part which has been used. So see the note, just read the note, growth stage and plant parts used. Which part has been used? For example, in wheat or rice, they have used 1 to 2 node stage, or it can be whole shoot. The whole shoot can be harvested. In oilseed rape, for example, it can be on pre-flowering stage, youngest mature leaf. In sugarcane, 5 to 7 months. What I mean to say here is that you need to define what should be the stage of the crop, what kind of crop it is, and what should be the age, and what should be the plant part that has been sampled. So in this case, you can see, for example, wheat and rice. For wheat and rice, the critical concentration is 3%. For oilseed rape, it is 3.5%. For sugarcane, it is 1.5%. So you see the variability in the critical concentration of the nutrients. So you need not to remember all these values, but you can see how this critical level varies with the stage of plant part use or species. So here critical content of various elements for deficiency and toxicity. See, in this case, it is toxicity also. For example, you see iron content. See the iron content. Deficiency 70 ppm is the critical concentration for deficiency, and leaf blade have been used, and the tilling is the stage. Tilling is the stage. Similarly, for toxicity of iron, critical level is 300, means it should be more than 300 ppm, and then leaf blade is the plant part and tilling is the stage. So this is how we can fix the critical content of the nutrients in different plant species. So you can see D for deficiency, T for toxicity, and the critical content, and the plant part analyzed, and the growth stage, at what was the growth stage. So this is how we define the critical concentration. Now, as I told you that critical concentration, soil testing, plant testing, all these efforts or all these approaches are good, but they give us just indication that whether a particular nutrient is sufficient in the plant or deficient or it is in excess. But they do not guide us that what should be the quantity of the fertilizer or quantity of the nutrient that should be applied. For this, we normally conduct fertilizer experiment and develop the response equations. We develop the response equation, and then based upon this, we can decide the optimum dose of the fertilizer. So what we do overall, we conduct the fertilizer experiment where we take some doses or some combinations of fertilizer, and we come out with the result that where we get the maximum returns, maximum yield. And then by using certain economics, we can work out the optimum level of that nutrient. So what is required, that conduct the field experiment, we obtain the result in response to fertilizer application, we get some result, some yield, and then we analyze the data, we go for ANOVA, analysis of variance. Means suppose we have used different levels of nitrogen, 0, 30, 60, 90, 120, 150, and against each level, you will get the yield, you will get the growth or yield. Whatever dependent variable you want, you can keep it. Then you will see the significance of the result, whether the difference in yield is genuinely due to fertilizer application. Then you go for ANOVA, analysis of variance, and your results are significant, means your F test is significant. Then you go for correlation and regression analysis. If your results are significant due to fertilizer application, then you go for correlation and regression analysis. And through correlation and regression analysis, we can find the response curves. And how to find the best response curve is known as response curve fitting. And once we have found out the response curve, then we can apply certain economic principles to find out the optimum dose of the fertilizer. Therefore, we go for fitting of the response equations. These equations start with the linear equation, quadratic equation, and then quintic, and there may be higher order equations. So here we need knowledge of agronomy, means how to produce the crop under different levels of fertilizer. Then we will analyze the data statistically, and then we will use economics also. Here, three subjects are important: agronomy, statistics, and economics. All the three will be combined. Now, let us see what is response curve. So functional relationship between input and output will be a response equation. So this is very simple. I already told you that what is production functions. So actually production functions are response function. Here response means if you make a change in independent variable, if you make some change in the input, how much change is there in the output. So such kind of relationship can be shown by an equation, and that equation is response curve. So equation can be represented in the graphical form also. Once you get a particular equation, say y is equal to a plus bx, so by changing the value of x, you can get the different values of y. You can get paired values, and those paired values can be plotted on the graph. So any equation can be converted in the graphical form. So relationship between yield and fertilizer rate is fertilizer yield equation, or fertilizer yield function, or fertilizer yield model. Model estimated from experimental data will give a realistic mathematical representation of the biological relationship indicated by the data. So we will make the mathematical relationship between input and output. That will be called as a model. So there are different models or different response curves. There may be different degrees of the variable, So if it is first degree means y is equal to a plus bx. Here power of the x is 1. The degree of x is 1. Therefore, it is a linear equation. It is a linear equation and curve will be a linear line or a straight line. It will be a straight line. There may be second degree response equation where power of the x is 2. So this is quadratic equation and the name of the curve is parabola. Then you may have third degree, which is x cube. X cube, the equation is cubic equation and the name of the curve is cubic parabola. Then you have x power 4. This is sorry, there is some mistake. It is quartic. It is actually quartic. Quartic and the curve is quartic parabola. This is mistake. This fourth degree, it is mistake. It is quartic parabola, and then fifth degree quintic and quintic parabola. So a production function, actually response curve is a production function, is a mathematical expression that describes the physical relationship between input and output. It is showing just the physical relationship. It is not economic relationship. So it is expressed by y is the function of x1, x2, x3, and xn. Now you can see the shape of different curves. I have just, in the last slide, I have given you name of some curves. So first one is your linear. Linear, you can see it is a straight line. Then you see quadratic, and then you see cubic is like this, and quartic, and then you have one more, that is exponential. Means increasing at increasing rate. Here in exponential, the output is increasing at increasing rate. So in this case, you can see the power of the E is variable itself, E power 0.34x. So in this case, the variable is exponent. So you have two kind of equations or two kind of curves. One is exponential curve or equation, and other is polynomial functions or polynomial models. There are two kind of curves or equations. So in exponential, if the variable appears as an exponent in the equation, it is called as exponential equation. The value of x can be positive or negative. It can be fractions or whole numbers, but b can be only a positive number. So we are not dealing with exponential equation. It is just to tell you that there are some kind of equations which are known as exponential equation. Other equations are polynomial functions or polynomial models. Here we will deal with polynomial functions. Polynomial models means these are the convenient and popular mathematical forms for empirical regression equations, representing relationship between dependent variable y and regressor variable x or w. These are independent variable, and following are the important polynomial equation. Polynomial means where your variable has numerical power. Variable has numerical power 1, 2, 3, 4, 5, 6, 7. So such kind of equations are polynomial equations or polynomial functions or polynomial models. So you see different polynomial models. Polynomial of degree 0 means y is equal to x power 0, something like this. So for there will not be any relationship. If your x is having power 0, there is no regressor variable. Now polynomial of degree 1, it is for linear or straight line relationship. Y is equal to a plus bx. So this is your polynomial of degree 1. Then polynomial of degree 2, this is for quadratic type of relationship, y is equal to a plus bx plus cx square. Then degree 3, you go on adding the term. You add dx power 3, then ex power 4 and so on. So you can go on adding the terms. Now polynomial of degree nth degree will have y is equal to b0, b1x. So this is how these polynomial equations are described. So polynomial of degree 1 is a linear response, which is a straight line. This is just summary. Polynomial of degree 2, 3, 4, 5 are curvilinear. They are known as curvilinear relationship or non-linear relationship. representing various forms of the law of diminishing return. So in curvilinear relationship like quadratic or quartic, we see the, the form of law of diminishing return. Law of diminishing return here means that in the beginning you will get very slow change, then very fast change, and then again slower change, and then it can become negative. So these curvilinear relationships follow the version of the law of diminishing return. Economic interpretation are made from these functions. Once we have found out the equations or models or functions that will fit our data, then we can put some economic principles to know the meaning, what does it mean. Then procedure for fitting different response functions to experimental data are available. There are certain procedures which can be used to see the relationship between input and output. Then procedure for applying economic principles to experimental data via different response functions generally worked out by the individuals. Means you can see the physical relationship between input and output, or if you are interested, if one is interested, you can go for economic relationship also. The linear response curve implies constant returns. If your line is a straight line, then your returns are always constant. Application of economic principles to this function is different form and simpler than the application to the curvilinear diminishing returns equation. Because in curvilinear relationship, your response varies. However, in this linear relationship, response is same. So economic calculation is very easy. But in curvilinear relationship, this response varies. Your level of input, first level, second level, third level, fifth level, the response may not be the same. So here some mathematics is used to get a common response across different levels of the input. Now comes the response curve fitting. Now, friends, response curve fitting means now you understand response curve. It is the relationship between input and output, or relationship between independent variable and dependent variable. Y is equal to f, x1, x2, x3, x4, like that. Now, how we can fit the response curve and what does it mean by response curve fitting? So, whenever we conduct the field experiment, we will get some data. We will use different levels of input x1, x2, x3. We will use 0, 20, 40, 60, 80, different levels of the input, and we will get different levels of the output. So we can join the points of the output. We can join the points of the output. But statisticians say that you have no power. You are not legally bound to join these points. We want a line that can represent these points. And we want that line to be the best fit. For example, if you get a cloth from the market and you want a shirt to be stitched by a tailor. You will go to the tailor and ask him to make a shirt for you, stitch a shirt for you. Then what the tailor will do, he will take some measurements. He will take the measurement of your chest, he will take measurement of your arm, your length, this and that. So tailor will take measurements, and then according to that he will stitch your shirt. Same happens here. We want a line, we want some measurement that can represent the data, that can represent the response data which we have got due to fertilizer application, or result that we have achieved due to different levels of input. So what happens when you plot the original data on the graph? Then no straight line will pass exactly through all the points, although many lines can be drawn. And we need to find the straight line which fits all points better than all. This is the problem. In other languages, what values of A and B in equation must we take? That gives us the best fit. Can we devise a measure of all closeness of the fit of the various lines which can be drawn? I will explain you, don't worry. It is also possible that data following the diminishing kind of curve, wherein non-linear regression would be better fit. So we need to see the choice that what kind of line we can fit for this data. The response curves are fitted by using method of least squares. The response curves are fitted by using the method of least square. So this method is used to fit the response curve. Just see the next slide. So this is how I can explain to you. See, if fertilizer experiment was conducted where you have 0, 50, 100, 150 different levels of the nutrient. On y-axis, you get the yield. Suppose some yield was obtained by you. And there are different points. Actually, this graph is not showing other points. There are 1, 2, 3, 4, 5, 6, 7, 8 points. So eight different levels of input were used. 8 levels of fertilizer were used in this case, and you get some yield for different levels. So now you get 8 points. Now we want to make a line. We want to make a line that will represent this data, because we cannot join these points. So we want a line that can fit this data, that can represent this data. So I can draw many lines. See the green one. Green one line may pass like this, and you see 1, 2, 3, 4, 5. 5 points are lying above this line, and 2 points are lying below this line. So this is one option. Second option, I can have the blue line, where you got 4 points above this line and 3 or 4 points below this line. See the purple line, the third one, where 2 points are below this and rest of the points are above this. So now I have green line, I have blue line, I have purple line. So which line is giving or representing this data the best? How can I decide it? How can I decide it? What should be the way out? So you see this dotted line. This dotted line. This is actually the best fit. This is actually the best fit. Now, why this line is best fit? How can I say that this line is best fit? So, how we do it? We use the method of least squares. Method of least square. See different data. First data is 3. This 3 you can see. So from 3 to the line, I can measure the distance. Next is 6. I can measure the distance from this point to the line. Then 8.5. 8.5 to this line, I can measure the distance. Then 9.5, then 9.9, 10.8, I can measure the distance. I can measure the distance. And there are certain points which are lying below this line. I can measure the distance of 8.6, how far, how much away it is there from the line. Similarly, 5.6, how far it is from the line. So I can measure all these distances. If I make the total, it will be 0, because line is passing through the middle of these points. So the total will be 0 of these distances. So what should I do? What should we do? We should square these values. We should square the difference from the line. So if we square these values, all values will become positive, because values which are lying below these lines will give you negative, and the values which are above these lines will give you positive. So better to square and then make the total of this square for the all points. That will be total sum of square. And the line which is giving the lowest values of the total sum of square is the best fit. Is the best fit. So I will leave you here, and I will start from where I am leaving. I will start tomorrow from the point where I am leaving. But you try to understand what is method of least square, what is response curve fitting, and I will repeat tomorrow from this point, response curve fitting. What is response curve fitting? and how you can understand the method of least square for response curve fitting. I will explain again tomorrow. And in the meantime, you can study from any statistical book. And I recommend you one book that is statistical procedures for I forgot the name, but that is by Gomez and Gomez. Gomez and Gomez is the best book for all of you, whether you are in WST or SSAC or agronomy. This Gomez and Gomez book is the best, and you can read one chapter is there about response curve fitting. So that is option for you. And if you like, I will send you that soft copy of that book, the PDF file of that book. But all of you, I feel very ashamed to say all of you that all of you are very ungrateful people. I sent you mail. I put some efforts in sending you mail, and you could not say a single word of thank. You are very ungrateful and very uncivilized people. And only one person replied. Did you get my mail I sent yesterday?
Yes, sir. Yes, sir.
So you did not
That
you did not get any training. You are not cultured people. And for me, it is not an issue at all. It does not matter to me, but it will matter to the people in your life. You will have many people in your life, your teachers, your friends, and whenever you go to interview, interview room, you just ask, may I come in, sir? Can I sit down, sir? Can I go out, sir? Thank you, sir. This, sir. So there you use it. But why don't you use it in daily life? Why don't you use it? Why don't you make it as a habit? It does not matter to me at all. It has no meaning to me. But if it is your habit, then you will be the loser. So with this note, if you want to say anything, you can say. But this is not a good behavior from your side. Believe me, it is immaterial to me at this stage. But I want to change your habit. You should be grateful, thankful to the people who are helping you. And I can tell you that civility costs nothing. Civics is a subject which teaches you to be a good citizen. So with this note, I thank you all. Thank you very much.
Thank you, sir.
thank you, sir.
Thank you, sir.
Thank you, sir.
I'm not
Thank you,
angry,
sir.
man. I'm not angry. Just I want to make you a good person. With this, you should not be ungrateful to the people who are helping. Thank you.
Yes, sir.